The component for our home fragment will get created each time onAttach is called. This isn't ideal. We should have the component mirror the lifecycle of our view model, so we can be sure that all scope dependencies for our fragment are following the same lifecycle. To accomplish this, we need to add a new scope for our fragment, as well as handle the logic determining when a new component is created. Lucky for us, the Jetpack ViewModel gives us a very simple way to manage fragment component lifecycles. In the DI project module, open the build.gradle file and add the ViewModel dependency. First, we'll create a new scope package and add a new file called screenScope. This will be an annotation class with the scope annotation, as well as the retention annotation with runtime as the value. You may know that runtime is the default value for this annotation in Kotlin. I just have a habit of explicitly adding it, probably a holdover from the Java days. Next, we'll create a new package called component, and a new file here called component ViewModel. This will be a class that extends ViewModel, and it'll have a mutable property. We can just make it a nullable any type, and this will hold on to our cached component. Override onCleared and set this to null. Next, create a typed extension function on ViewModel store owner called getComponent. This will take in a function argument that just returns the generic type. We're using ViewModel store owner as the extension function target, since it will work for both fragments and activities. We'll get a reference to our component ViewModel by creating a ViewModel provider, passing this as the owner, and then passing in the component ViewModel class literal. This works just like it would in a fragment, where we'll get a new ViewModel if this is the first attempt to get this type. Otherwise, we'll get the existing instance. If the component property on this ViewModel is null, we call the createComponent function that was passed in and assign that result to the property. Now we can simply return ViewModel.component and suppress the lint warning we get. Now open the home component file. First, we'll add the screenScope annotation to the component declaration. Then we're going to update our extension function here to call getComponent, moving the Dagger home component factory logic inside the block. Then we move .inject this to be called after the getComponent block. Let's also open home ViewModel and add the screenScope annotation here. This isn't strictly required, since the ViewModel framework will handle the lifecycle in our fragment, but this will make the Dagger dependency lifecycle more explicit and easier to follow. Now what happens if a config change occurs and our fragment gets recreated? We'll be injecting it with the component we already created. Our component can now have screenScope dependencies that will survive as long as the ViewModel would. And this concept is slightly less vital than it was before the Jetpack ViewModels came around, but it can still be very handy if you want to avoid needing separate ViewModels for independent objects that you'd like to retain for that lifecycle. You could even go further and choose not to use a ViewModel directly in your fragment at all. You can now have a screenScoped presenter, controller, or whatever you want to call it, and still get the lifecycle benefits of using a ViewModel directly. For this course, we'll continue using ViewModels in our fragments, but with nested Dagger scoping like this, you're really free to make your own architecture. Now if we look at the generated Dagger home component, we can see that home ViewModel provider is using the same double check provider that we saw in the application component. This means that for one instance of our home component, there will only be one instance of our home ViewModel created, no matter how many times it's injected.